All right. Good morning, everyone, or good afternoon, depending on when you're watching this video. Today we're going to be talking through, as the section title says, we're going to be working through some function operations. And really, we're just going to be taking a couple of different functions, so the three that are listed here, and working through the four different operations that you see here. So what I would like you to do is set up your note sheet in this format. Go ahead and get everything that you need recorded, the essential question, the section title, today's date, and we'll go ahead and get started. So I would maybe pause and then resume when you're ready. All right, so our main focus is, as I stated before, we're going to use the following functions, so f of x, g of x, and h of x, to perform the different operations that are listed in each corner. So we're going to work through what does the notation look like, if I want to change the input, what does that look like, and then just kind of go through some different examples that way. So first I'm going to start with addition. So if I'm adding, I guess one thing just to be kind of mindful of is the notation that you could be exposed to. So I'm going to just start with using f of x and g of x. So if I want to add, you may see notation where they're both in one parentheses, and really all that means is we're going to take f of x and add g of x to that. Now f of x obviously has something that it's equivalent to, so f of x is equal to x squared minus 5. So in the spot where I have f of x, I'm going to replace it with x squared minus 5. And then likewise do the same thing for g of x. So g of x is equal to this entire expression, so the 4x squared minus 3x plus 2. So that's what's going to get filled in that spot. And then from there, it's just a matter of combining like terms. So I see these two terms that can go together. So that's going to give me 5x squared. There's nothing that's going to go with this negative 3x, so I'm just going to put that next. And then lastly, if I take the negative 5 and the 2, that's going to give me negative 3. So if I were to add these two functions together, the result would be 5x squared minus 3x minus 3. If you need more time, go ahead and pause. Otherwise, I'm going to keep moving on, and then we're going to move on to subtraction next. So subtraction is pretty much going to be the same as addition, however, we're just going to be subtracting. So I'm going to use a different color here. So let's maybe do g of x minus h of x, and I'm just picking randomly. So the notation that you would see would be g minus h of x, and that just means that we're keeping the input of x. And so again, if I expand this out, this just means that g of x minus h of x is essentially the operation that we're going to be doing. So I'm going to, in parentheses, put 4x squared minus 3x plus 2 in the space for g of x. And then in the space for h of x, I'm going to fill in what h of x is equal to, which is the 3x plus 2. Right, now subtraction is tricky sometimes because this subtraction needs to be applied to all of the components. So what that really means is if I rewrite the first one, I can drop the parentheses at this point, and then if I subtract 3x, subtract 2, then I can now proceed just like I did before. So I can maybe find some like terms. So I see these two terms that can go together. So I'll rewrite the first one and then have negative 6x, and then these two will combine together to give me 0. So I can either put plus 0 or I can leave it just as is. So if I were to subtract g and h and do that in that order, I would end up with 4x squared minus 6x. Again, if you need to pause, please feel free to do so. I am next going to do multiplication. Okay, so similar setup. We're going to do f times g, okay, and that dot right there is just implying multiplication. Let me just use a little bit of a darker color. Okay, so again, all that means is we're going to take f of x, whatever that is equivalent to, and multiply it by g of x. So f of x times g of x. So in this case, f of x is equal to x squared minus 5. And then I'm using parentheses intentionally because I'm going to use that as a way to show the multiplication. And then we're going to do times 4x squared minus 3x plus 2. Okay, now I know it seems a little intense because we have 3 terms, but if we just kind of take it one piece at a time, I think we'll be okay. So if I do x squared times 4x squared, we got to use a little bit of our laws of exponents. So it's going to give me 4x to the 4th. If I do x squared times negative 3x, it's going to give me negative 3x cubed. And then x squared times 2 is just going to give me positive 2x squared. Right, now that's only one piece of the puzzle. I have to now do the same thing here. So I'm going to take negative 5 times 4x squared, so negative 20x squared. Same thing, that's going to give me positive 15x. And then last but not least, that's going to give me negative 10. And then my final task is just to look for some things that can be combined. So it's looking like those 2 terms right there and then nothing else. So I'll rewrite the things that didn't change. So 4x to the 4th minus 3x to the 3rd. That's going to be negative 18 x to the 2nd plus 15x minus 10. And then keep in mind that when you're combining like terms, the exponents don't change. So that's why all of them just maintained the same exponent. All right, last but not least, we're going to move on to division. Now, there isn't a whole lot that division, there's not a whole lot that we know up to this point that we can do with division. So if let's say I wanted to do f divided by h of x, again, all that implies is I'm taking whatever f of x is equal to and dividing it by h of x. And so again, I'm just going to rewrite those representations. So f of x is x squared minus 5, so it's going to be on the numerator. And then h of x is 3x plus 2. And since x squared minus 5 can't factor, there's nothing really that can simplify, then this would actually be my final answer. But if, let's say, I wanted to find f of h of, let's say, negative 2, what I could do is I could plug in negative 2 into this already written out expression in for all of the x's. And then just do some simplifying. So again, if you need a calculator, please feel free to use one. If I do negative 2 squared, remember that's positive 4. And then if I have 3 times negative 2, that's negative 6 plus 2. So this is going to simplify to negative 1 over negative 4. And then that will simplify to 1/4. So just trying to throw in that if you wanted to change your input to a number, that's something that is still definitely something that you can do. What I would like you to do is go ahead and when you're ready, move on to the next video that's listed in the Google Classroom. Thanks.